Hello engineers, welcome back. In the previous video, we got an introduction to graphs. We understood the terminology and concepts of a graph. In this video, let's try to understand the concept to represent the graph in memory. We will study the concept of adjacency matrix, which is one of the ways to represent it in a memory. I hope you're ready. Let's get started. So this is what we're going to look at today in this video. We'll see what is an adjacency matrix and we'll try to code it in C++ and then we will discuss time complexity, right? So let's get started. So what is an adjacency matrix? So as you can see, this is a matrix, right? So obviously it is a 2D vector or a 2D array. And then it is called adjacency, which means it represents the adjacency in the matrix. Adjacency is nothing but neighborhood, or we can say edges. So let's say we have a simple graph like this. Let's say we have a vertex called Sam. And then we have Tom, who is a friend of Sam. And then we have Jerry, who is also a friend of Sam. Okay. So let's say we need to represent this kind of a graph in memory. So how do we do that? So we will use the concept of 2D vector. So our 2D vector or a 2D array will look like this. So we will use a 2D vector. So let's say there are 3 vertices, right? Sam, Tom and Jerry. So we will make a matrix of 3 by 3 like this, 0, 1, 2, 0, 1, 2. Okay. And here 0 represents Sam, 1 represents Tom, 2 represents Jerry. Similarly, on the columns, 0 is Sam, 1 is Tom, and 2 is Jerry. And we will initialize everything with zeros. We will initialize the whole matrix with zeros. Okay, this is how we will create our initial matrix. So if there is a 4th vertex to be added, we will add it. Let's say Harry is getting added. We will add a new row to the vector and we will make everything 0. We will also add a new column for Harry and we will add all zeros here. Okay. So this matrix will become 4 by 4. So that is how we can represent any number of vertices in this matrix. Okay. Now, how do we represent the adjacency? So let's say I want to represent this relationship that Sam is a friend of Tom. So how do I do that? So every row is one vertex, right? So Sam also has a row. So I go to Sam's row and I visit Tom's column. So I go to Sam's row and I visit Tom's column. So that is 0th row and 1 column. And I will change the value to 1 like this. Like this. Now 0 represents that there is no relationship between them and 1 represents that there is an edge. Because this is an undirected graph, if Sam is a friend of Tom, automatically Tom is also a friend of Sam. So we will do the same thing from Tom's point of view as well. So what will we do? We will go to Tom's row and Sam's column and we will change it to 1 like this, right? And what about this one? Sam is also a friend with Jerry, right? So we will do the same thing from Jerry's point of view as well. So we will change these 2 values. Okay, and this will be our final matrix. Okay, so the ones represent that there are edges, there is a relationship between them, and 0 represent that there is no relationship. Like we can see here, from Tom's point of view, there is no relationship with Jerry, right? So let's see how we can code this in C++. So I've created a new folder called graphs and I've created a new file called adjacency matrix and I've created the base template. Now we can just get started. So let's see how we can do this. So what do we need? Let's create our graph class. And in the private space, we will need 2 things. One is a vertex count. This will keep track of how many vertices are there in our graph. And then we will need the actual matrix. So that will be a vector of vector. Vector of int and let's just call it matrix. So why is it vector of int? So inside the matrix, we are representing all numbers and every row is a vector. So this is a vector, this is a vector, and this is a vector. So every row is a vector, and inside each vector the values are integers. That's why it is a vector of int, right? Now let's create our public methods. Let's create a constructor. We will simply use it to initialize our vertex count to 0. So initially there are no vertices in our graph. Now let's add a graph, add a vertex. So for adding a vertex, what do we need? First we will increment the count vertex plus plus, and then we will add a new row to the matrix. So matrix of matrix dot pushback, and we will create a new vector of int and push it into the matrix. And what will be the size of this vector? It will be the size of vertex count, right? So initially vertex count was 0. Now the vertex count is 1. So our vector will be of size 1. And then we will initialize it with 0. Okay. And when we call add vertex again, the vertex count will become 2. And when we add a new row, it will be of size 2 with 2 zeros. So it will look like this. So for the first vertex, we have created one row with index 0, and this is having only one column with value 0, right? So this is 1 by 1. And when we add the second vector, we will have 2 rows and 2 columns. The first row was having 0 here. Now the second row will have 2 zeros, right? When we had third vertex, there will be 3 rows and 3 columns. So the first row was looking like this, second row is looking like this. Now the third row will look like this. It will be of size 3 with 3 zeros. Okay. So as you can see, there are gaps that are being formed here. We need to fill these gaps with zeros, right? Because otherwise it will be an incomplete graph. So let's do that. So after we create every row, we go back to the previous rows and add zeros to their end. So for int I equal to 0, I less than vertex count minus 1, only up to the last row, and then I plus plus. So we will simply say matrix of I. We go to the ith row and say pushback 0. Okay, we are just adding zeros to the end. So what will happen now? So when I added 2, I added this new row. This is a new row, and I go back to the previous row and I add 0. Now this is a complete graph. So when I reach here, it will be filled like this. Now when I add this new row, I need to go back to the previous 2 rows and do pushback of 0, 0. Okay, now this is a complete graph. So when there is a fourth vertex, it will be like this, and I just need to add zeros to the end, right? So that's how it works. Now this is a filled complete graph. So I think our add vertex is done. Now let's see how we can add edges. So let's create a new method called edge, add edge. This will take in 2 things. Let's call them int u, int v. And what does this uv represent? This represents the row and column values. Let's say I want to represent this edge, that Sam and Tom are friends, right? So how do I do that? Like we discussed, I will go to Sam's row and Tom's column. So this will be matrix of 0th row 1 column, and then I will just change it to 1. And I will repeat the same thing on Tom's column, Tom's row as well. So this will also become 1. Okay. So we will just change the value from 0 to 1. So we say matrix of u and v is 1 and we will repeat the same. We will say matrix of v and u is also 1, and that's it. Our edges are done. Now let's create a function to print the graph so that we can see if our logic is working fine or not. So let's print our graph. So how do we print it? First this is a typical 2D vector print. So we will use nested loop. So we will say first int I equal to 0, I less than vertex count I plus plus. These are our columns. Now let's look at rows. Int j equal to 0, j less than vertex count j plus plus, and we are simply printing matrix of I and j. Okay, and after every row we can do cout and L to a new line, and we can do a cout at the end of the whole print as well. Okay, so that is our print graph. Now let's quickly create our graph. So we will simply say graph G, and what do we need? We need 3 vertices, add vertex 3 times. Okay, and then let's print it here. We should see all zeros. Now let's add edge. So how do we add edge? So we need to add edge between Sam and Tom. So Sam is 0, Tom is 1. So we will add an edge between 0, 1. Similarly, we need an edge between Sam and Jerry. So this is 0, 2. So after we add this, let's print it again. Okay, I think that's it. Let's run and see. Okay, so this is our graph. So first there are all zeros. This is the initial state, and then let's compare. So we have 0, 1, 1, 1, 0, 0, 1, 0, 0. So we have 0, 1, 1, 1, 0, 0, 1, 0, 0. So our logic is working fine. Okay, so if you want to represent it like this instead of 0, 1, 0, you can use an unordered map and represent the columns and rows like this. So we can use a map, and let's say 0th index will become Sam, and 1 will become Tom, and 2 will become Jerry. So while adding a new vertex, we can just add a new entry to this map and then use that for just printing for visual representation of this, right? But internally it is just a 2D matrix with indices 0, 1, 2, right? So that's how we can code the adjacency matrix to represent a graph. Okay, now let's discuss time complexity. So the time complexity is like this. So if I want to know if there is a relationship between Sam and Tom, so I will go like this, right? So the time complexity for a lookup is O of 1. Why? Because once I know the indices, I know where to go. I know the index 0, I know the index 1. I will simply go to the 0th row and first column and I will find my value. So this is a constant operation. There is no other operation involved. It is a constant lookup. Okay, so the time complexity is O of 1. What about space? Space is growing for every vertex. So we can see this here. For the first vertex, the size of the matrix is 1 by 1. For the second vertex, the size of the matrix is 2 by 2. For the third vertex, the size of the matrix is 3 by 3, right? So the space is growing at a time of v square, v being the number of vertices in the graph. Okay, so for every vertex, we are adding additional space to increase the size of the matrix and keep all relationships, right? So it is costly in terms of space, but lookup is instant. It cannot get any faster than this, right? So that is the trade-off we need to remember when we are dealing with adjacency matrix. Okay, so that is the time complexity. So I think that's it for this video. In the next video, we'll look at another method to represent the same graph. It's called adjacency list. So we'll see how that looks and we'll code it and discuss. Okay, So thank you so much for watching. If you have any questions, definitely ask me. Don't forget to leave a like and comment if you have any questions or suggestions. Do bookmark the playlist and subscribe to the channel if you haven't done already. Thank you so much for watching. I will see you in the next one. Cheers.